Alright, in this one they asked me to graph y is equal to secant of x between negative 2 pi and 2 pi. So, remember you always put 4 tick marks. There's 2 pi, there's pi over 2, and pi, and 3 pi over 2, and then you do 4 tick marks on the left. There's negative 2 pi, negative pi over 2, negative pi, negative 3 pi over 2. Okay, remember they asked me to graph secant. Secant is the reciprocal of cosine. So in order to graph secant, I'm going to first dot in the cosine function. Remember cosine starts in the top, cuts the axis, reaches the minimum, cuts the axis, reaches the maximum. So if I just dash that in, it looks like that. Kind of remember cosine looks like a tulip, kind of. Alright, and then I'm going to dash it in on the left side. Notice it looks like another tulip, just like that. Everywhere that cosine crosses the x-axis, that's where I have my vertical asymptotes. Okay, and then they just kind of share this here. Sorry, I'm at school and that's the bell. It's okay, I can stay. And this will be down here, and this will go up here. So there's the graph of y is equal to the secant of x. Then they ask me, where are the vertical asymptotes between negative 2 pi and 2 pi? So the vertical asymptotes going left to right start at negative 3 pi over 2, and then we have negative pi over 2, and then I have positive pi over 2, and then I have 3 pi over 2. Okay? If they wanted me to generally say it, the whole thing, I could say it happens at odd multiples of pi over 2. Sorry, odd multiples of pi over 2. The next question they asked me is, where is secant of x equal to positive 1? So look up here at your graph. Since I just graphed it, that was really handy. So it looks like it's positive 1 here, here, and here. So that would be at negative 2 pi, and at 0, and at positive 2 pi. That's where it's positive 1. If they asked me where it's negative 1, it would be negative pi and positive pi. All right, easy enough.